So I want to start by introducing, so people, like some of my students ask me, so what's the difference between AI, machine learning, generative AI? So in one picture is AI is the goal. So given the data, we want to address a specific problem. Well, machine learning is the methodology of AI. So we propose a function, try to implement the goal. So that's the methodology of AI. Well, deep learning is a subcategory of machine learning. So it's more like a more complex model to implement what machine learning want to achieve. Well, generative AI is a special topic for deep learning. So given the input content, we try to generate the output content. So including multimodal. So for example, input can be a text, output can be a video or a voice or something else. So that's like a generative AI. So that's a very general uh, a description of what generative AI can do for us and how we're going to use the traditional machine learning method. So there can be three different stages of AI. So we, in the past like 30 or 40 years, we spend a lot of efforts in the narrow, we call it narrow AI. So it means AI will try to address one specific problem. And we right now stepping into not fully there yet is a generative AI, sorry, general AI. So general AI means AI can break the boundary of certain domain. So it can transfer the knowledge from one domain to the other. So address more comprehensive different kind of tasks. So that's more like a large language model, GPT, generative AI, what we can do right now. So stepping into from narrow AI to general AI, we're not fully there yet. So what if in the future? So we want to eventually machine will do something more than just using existing knowledge. So maybe can do something more than, so for example, if I say, hey, I give machine learning a kind of a cancer cell. So I want a machine learning to give us like mRNA vaccine. So, this is a very hot area. So they have a very ambitious goal, like in 10 years from now, machine learning algorithm, AI algorithm can deal with all type of disease, including cancer. Okay, so it means they will provide us a very personalized vaccine, mRNA vaccine shot to deal with all kinds of cancer. So that's more like a super AI. So we don't have this drug yet, but the model will learn based on what we have right now and develop a new drug for each individual patient. So that's like super AI. So we hope this is gonna come in the future years very soon, but we're definitely not there yet. This is NVIDIA stock price. So if you have 401k recently, you probably cry a lot like me. But so you find that if you purchase a lot of NVIDIA stock like 20 years ago, 10 years ago, you will be very happy right now because you're probably a millionaire. You find that this is like when ChatGPT come into play. So you find NVIDIA price going up very dramatically. Okay, like dozens of times very soon. And then because of the surge of the AI needs, so a lot of a big company like Google, Microsoft, and Facebook, they start to compete, right? So purchase a lot of GPUs for generative AI usage. But recently, I want to show you this one because recently DeepSeek model. So I just give my students 3-hour lecture. So why DeepSeek is threatening NVIDIA price? We spent 3 hours talk about this topic. This is very interesting. So including their algorithm. So why this algorithm may threat the stock price of generative AI, stock threat like NVIDIA price. This is a very interesting. So we know generative AI is increasingly useful, but there recently people start to challenge how generative AI being used and why generative AI can dramatically change our life, or this is just not something very that significant. So there's a lot of challenges. For example, this one is probably this one come from New York City. Say, hi, GPT, finish this building. And of course, they say this human is quite important. Okay, human is more important than the AI model. But I would like to challenge a little bit here because recently this is some more than Tesla, but also some other factory. So right now the robots start to work in the factory. So start to replace a human in the manufacturers. So and some students ask me, so should I get a maybe CS degree or some other kind of degree? So which domain is safer? But my answer is probably a little bit different. We save some time. We don't show you the video, but probably manufacturer is not that safe right now, and also threatening some of the CS work. So this is a traditional work. So like the workers in assembly line work for manufacturer, but right now, some very few workers, they can train the robot by using some VR device. So it means that the robot will probably learn something from the worker by using the VR device. So without a lot of training data. So here in the earlier when we use machine learning, adopt machine learning. So in the assembly line, so if we make a little bit change, just a tiny bit of change of the product, so it means we will need to recruit quite a lot of software engineer and hardware engineer. Okay, and so because whenever we made a little bit change, so we need them help. But right now, after the workers and plus the robots replacing the training, this training process, try to replace traditional assembly line. So there is a chance we don't need too many. We will cut a lot of software engineer and hardware engineer. So I would say no matter you work for manufacturers or you work for computer science, you may want to pay attention to the challenge of AI, generative AI especially. I think Hollywood is one of the first, the writers right now feel really worried about their future, okay? So part of their goal is to stop writing, stop using GPT to write a story. But I'm pretty sure we have some debate in my class. I'm pretty sure that if United States of America do not use GPT for story writing, Hollywood probably will disappear in a few years because it may go to the other country, which will allow GPT usage. Okay, so this is really challenging, not just challenge traditional industry, movie makers, but also computer science. Like this one, CS major, right now there can be like a 30% of the job replacement entry level by using GPT. So this is really some problems we all need to investigate in the future. Okay, so this is a very interesting but important problem. So when we deal with AI and data science, so we have right now two choices. One is using the specific model. Let's say the first one, specific model. So one model deal with specific task. The model is more like a learner. So we will train the model to do something very specific. For example, text classification. For example, auto driving. So that's domain model. But we have another choice. We can use a general model like a GPT model, like large language model. So work like a brain. And the good news is you don't need to provide a lot of training data, maybe a little bit training data, maybe no training data at all. But the model can do a pretty good job. The good news is very easy for deployment. So you can think in the traditional, or when we use traditional machine learning models, you may need to recruit like programmers. You may need to find really good programmers to pay them very high to make your job, to make the task deployed. But right now, for the general AI, general domain model, and you don't need to like GPT model. I think even I'm not a programmer, I know nothing. Right now, my daughter, 80 years old, talk to GPT all the time. And so she don't have to be a programmer and she know how to deal with some AI task. So that's the difference. So these two, one is the learner, another is the brain. So those two models, hopefully in the critical domain, there is a chance these two models can work together. Okay, so here, this is my main point for today's presentation. So in the critical domain, like healthcare, like a cancer drug development, like for example, like legal science, if we want to train an AI lawyer. So probably we need to use some general model, but we also need to take advantage of a domain specific information. So hopefully these two models will work together and help each other, mutual benefit each other. So that's going to be something very interesting, I believe. And so I give an example. So if for classification, that's very easy. Machine learning 101 student can deal with it. So given the input is a news article, and the output can be classified into different categories. But right now, after we have the generative AI, so we can give the news article content, and we can say the category of news is the model can decipher this news category automatically. So we don't need to train the model at all. So that's the difference for the classification model and general model. So they can use in the same result, but different way. The large language model, what it's going to do is the next token prediction. So we will use the general knowledge to predict the next token. This is something we can do. All right, then let's jump into domain specific. So for domain specific, right now we train a model. So let's say we already have a GPT model. We all know those words, fine-tune the model, fine-tune the model. So when you have a general model like a GPT model, you can fine-tune the model with maybe some domain feedback, with some user feedback information. I give an example. Like for the GPT model is OpenAI is a black box, so we don't know what's inside, but we know Llama, we know InstructGPT, and so based on their paper, they use a very successful model. It's called human judgment-based reinforcement learning. Okay, reinforcement learning with human judgment data. I give an example, like if I ask a question, where is WPI? So because we collect data from everywhere in the web. So the web data is very dirty, it's very noisy. So when we use only for the next token prediction, if we just train the GPT model, the model response can be where's MIT? Because on the web, these two questions can be stay together. Okay, so next token prediction, maybe the model will respond, where's MIT? Maybe it's Worcester, Massachusetts, maybe say, I don't know. So when we have a lot of data for GPT training, so the data is very noisy, then the model can be polluted. But we can, in the specific domain, we can use a little bit of human intervention, just very small. So here we talk about billions of training data. Here we talk about thousands or tens of thousands of training data. So we can improve the model performance effectively. So here, for example, we can sample some questions, random sample. That's a random sample, some questions, and we can give some different type of answer, and we can ask a human to give us some judgment. Okay, very big data and very small data. And so, for example, I push GPT to generate 3 different answers given the same question by using the temperature. Temperature, this control how diverse the result is going to be. So here, given this question, I push GPT to generate 3 different answers, and I give each one ABC, and I find a user. I say, tell me, ABC, what do you think? Users respond, maybe B is better than C, is better than A. And so here, we will train the GPT model with reinforcement learning. It's not SFT, it's not fine-tuning, traditional fine-tuning, but it's a reward model. Reward model means GPT model will very likely to learn some knowledge, domain knowledge. For example, GPT will know when you ask me a weird question, GPT prefer a location more than, I don't know, more than another question. So this is GPT learn by using the reward model. Reward is if you give me location information, GPT answer will get additional reward. So that's the reason why GPT model can benefit a lot, even from small amount of, why is it small, still maybe 20,000 pieces of user feedback. Okay, that's the reason when you use GPT, sometimes GPT will give you 2 answers. Say, I like this one, or I prefer this one, right? So then you provide feedback for free. So that's what you do on the training. But right now, if we, this model works so well. Okay, everyone's using that for model GPT model fine-tuning. But if I change the question a little bit, right now, where's WPI? Probably someone will know that. Well, if I change the question just a little bit, if I change the question a little bit, this question, which following is the common target for cancer immunology. So which is the answer? So can someone answer this question? It's really hard, right? Actually, it's not that hard if you already took some drug discovery class, biomedical domain class. If you took like those class entry level, probably you can answer this question. The answer is CPD1, which is a kind of the immune T cell response to deal with cancer. Okay, to deal with cancer treatment. So I think if you have some basic domain knowledge, then maybe you can answer this question. But if I change another one, it changed to another question, like I'm sorry. like this one. Okay, can someone answer? I think 99.99999% of people cannot answer the question because this token is very, very confusing. It's the kind of a very, very specific like functionality of the cell. So very few people in this world really understand what this token means. Okay, so here I give you the example to tell you that when we adopt large language model in very specific domain, for example, for cancer drug development or healthcare, and it can be really, really expensive to find an expert like this guy, which can answer this type of question. It's very, very hard. Okay, per question, when we really recruit some cancer expert, like $20 per question, easy question, $20 per question, or they can pay by hour, like $340 per hour to answer the question. And their availability can be really low. And they say, I can only work for you like 2 hours per week, something like that. So their availability is very low and they're very expensive. And when we provide some question to an expert, and the expert, even though he or she say, I don't know, we still pay $20. This is really, really hard. Okay. Well, another thing interesting is that if we have 3 different cancer experts, they all deal with cancer. They are very, very well known. They're very great cancer experts. But because their subcategory is different, so some will deal with lung cancer, some deal with cancer cell, another with T cell. So when you ask different questions, so some of them may say, I don't know, because this is not my domain. This is not my area. So those doctors, those experts, they're very domain specific. It can be extremely expensive to ask them to provide you any feedback. So that's one this is the one challenge. Today's topic is opportunity and challenge. So here comes the first challenge is resources. I would say more than funding. Okay, availability of the domain expert and how much you need to pay them. Yeah, most of the time we're not billionaires. Even if you are billionaires, it can be really hard to recruit a very high quality expert to answer all the questions you have for the model training. Okay, so this is the first challenge we're trying to solve. Okay, so let me give you a very easy scenario here. So for example, we have 4 domain experts. So their availability and price can be different. So there can be some senior and some PI, maybe some senior, maybe some junior, maybe some RA. Okay, their rate can be a little bit different. And we know some experts deal with cancer, MRA, some can be experiment data analysis. So each one, their expertise is very different. Okay, and for the large language model and the GPT model, we need to train the GPT model to ask a question. That's interesting. So earlier, when we train the model, we sample the question. We sample the question for user feedback. But right now it's different. I tell GPT that I only give you like $20, or I only give you $100. So we will need to train the GPT model or the large language model to ask questions for those domain experts. So this is an active way. Okay, GPT model first may say, okay, I need to know something if I want to be an expert in this domain. Or if I want to solve a problem, I need to understand, okay, I need to know more about mRNA, I need to know more about T cell, I need to know more about DNA design. So they will need to ask the question, actively approach the right expert and ask the right question with very limited amount of funding. Okay. All right. So let's see the scenario. So maybe there's a GPT model, and we have a lot of questions the GPT model did not know yet. And so the model will say, okay, this is the first question, very important. I will ask the first guy. The second question, I don't care. The third question, I go to the fourth one. That last question, I go somewhere else. So here, this is what we want to train the GPT model to know. This is not a human design. Okay, this is GPT will very actively do this kind of a task. And this is how we train the model. We give GPT model every time $100. Okay, we say I only give GPT model $100. And I say GPT model, you can use it whatever way you want. But I will tell you that we have domain expert here, we have a database, and their availability can be different. So GPT can simulate the process by asking questions. So for each domain expert, we will provide a price and availability. Then GPT model will try to the first task is a user start expert profiling or computational profiling. GPT model, before they start ask question, GPT model will first read all his or her publications. Okay, read everything. And GPT will generate a profile for each candidate expert. Okay, then we know, okay, this guy knows cancer, this guy knows T cell, this guy knows DNA a little bit, but not too much. So the model will know everything and also estimate how much money he or she will need to charge if I ask one question. For example, by using H index. Okay, so for example, Dr. Ding H index is very high, my H index is just okay. And so maybe my assumption is ask one question for him, $100, ask me only $10. Okay, I'm cheaper. But GPT model later will make decision whether they want to ask Dr. Ding only one question or ask me 10 questions. So the GPT model will need to make such decision. All right. So then we will generate those expertise for each domain expert. So, you know, in the PubMed database, very large. So we may have like hundreds of thousands of authors. So maybe we can do something like that. Okay, for each one we can train a model to do that. And then, okay, and then the model will say, okay, so I want to ask like Q3, okay? The model will need to train itself, say, okay, I really want to ask the third question to this guy, but unfortunately, if I do that, I will have to lose $20. So the model needs to train itself. Okay, we need to train the model to be frugal. Okay, this is very important. So we want the model, we want to train the model to be frugal, and we want to train the model to approach the right person in any curriculum, like lawyers and judges or the domain expert, like the cancer treatment designer, something like that. So this is it's not working so well. Okay, so here when we have domain model, so let's say this one, GPT model will say I have some question here, like mRNA, PD1, GFR. So all of those are terminologies for cancer drug design. So maybe they will say, okay, the model will say, okay, I really want to know more about mRNA. I really want to know a little bit of the PD1, something like that. So this is the model's needs right now. And the model will, okay, so if the model sample, let's say the first one, sample a question for mRNA, if the model first sample asks a question, then which means the last question, earlier, this is very important, but right now the model will panic because I already know something about mRNA. So maybe this question is not important that much. So the probability of importance will decrease for the last question because GPT model, when they have very limited resource, they don't want to ask like something like very redundant. Well, GPT model will also say, okay, in order to deal with cancer drug design, so mRNA and EGFR is a kind of cancer mutation, and these two things can help each other. They provide each other very important information. Then the importance of EGFR after the first annotation will increase. So this is the model we need to learn in a specific domain. So this is going to be helpful to train the GPT to ask very high quality domain question. Once again, with only $100. Okay, we always play the game when we train the model. We only give GPT $100. So GPT model, let's say, use the same thing. You can ask Dr. Ding just one question. He's much better than me, but he can also ask me 10 questions. So which can be a little better, right? Which is better? I don't know. Okay, GPT will need to train the GPT to make decision depend on the goal. All right, so here, the question asking strategies, ask questions. So the large language model we need to train the model. All the question sampling need to be collaborative with each other and compete with each other. Collaboration means some questions, when we merge together, they will generate something more powerful. The model will need to learn that, but also need to learn how to compete with each other. It means if I ask some question, I will lose some money, so I won't have enough money to ask some other questions. So the model will need to learn this strategy. So the competition and the collaborations. So that's very important thing. And so when we train the model, this is our mathematics, okay? We don't have something more than that. So we train this model is called multi-agent reinforcement learning. So OpenAI, some others, they use single agent reinforcement learning because each time the agent only pick one question to ask. That's easy. But right now, we train a multi-agent reinforcement learning model because each agent will sample a question, but all the agents before asking need to compete with each other. So which question should be prioritized and which question is more important based on availability of the domain expert and based on their importance. So the model will need to compete with each other before they ask whatever question. So this is the model design. I won't go too deep here, but we have the left part is use PO learning to deal with who can annotate which task, while on the right we deal with which questions should be prioritized for asking. Okay, and the model deal with the annotation cost, expert availability, and the agent collaboration and computations. So that's the whole model design. All right. So when we train this model, we use purposely using a 2023 large language model, which is older, and we train that with last year publication. So 20 publication published in 2024. Then 2023 large language model do not know 2024 papers yet. Okay, because those are new paper beyond this knowledge boundary. And so we will extract some QA pairs from the publication list, and which is GPT say, I don't know, I cannot answer all of the questions. But some questions can be answered, some cannot. So we purposely find a collection of questions that the large language model cannot answer. But the paper also provides some authors, right? The authors, intuitively, the authors can answer the questions. So we will need to train the model, okay? So we will tell the model that the model, if cannot answer the question, but the authors can answer, then we will train the model to sample the question and ask those authors. But of course, we provide a much larger collection of authors, so we will less negative samples, but those are the positive samples. So finally, we train a model with a lot of questions extracted from 2024 data. And so finally, the question strategy come from, we provide a reward function. So the reward function is when we ask a set of questions here, or sample some expert here. So we hope we given $100, we can answer as many questions as much right here in this whole collection. For example, the first $100 after we asking, maybe answer like 2% of the question here from the group. For the second time, given also $100, we can answer like 5% of questions, which is much better. And we're going to use this percentage as the reward function to train this very big model. So finally, the domain model will become quite smart. And they know that, okay, I only have limited resource funding, so I should approach the right person to ask the right question. Okay, so that's something the model can learn. I think this paper very likely will be accepted in ACL this year. So this paper will come, I think, very soon. Yeah, it will be available very soon. All right. So the first part, we talk about model fine tuning. So we have a lot of data, okay, a lot of data from open web. Okay, so this is a very big data, supercomputer deep learning model, but that's what we call the pre-training model. But we also have some small models in your target domain. So this is a very small amount of data, maybe a affordable computer. You don't need to use a deep learning model, but here, this is a fine-tuning part. So my strategy is when you adopt the very large unsupervised, it's a pre-trained model in your target domain, but if this is a sensitive domain, so pay attention. Your fine-tuning data, you may need to deal with the cost and annotator availability, domain expert availability. So which is a very important thing you want to take into consider before you design your model. So the next part of the talk, I'll deal with, we've addressed the first part, which is a complete task problem. The first part is fine-tuning problem. Well, the second part is, what if we already have a large language model in a specific domain? But the problem is, we want the model to deal with more complex tasks. For example, here is drug development. Let's say we want to develop a drug based on gene or based on the protein structure for like cancer, for Alzheimer's disease, or for some other rare disease, which is really hard, very, very hard. This is very complex. This is when human develop a drug. So what do we want to consider, okay, with multiple different factors? So if we train the model, want to deal with something like that, so which means we need reasoning. So that's going to be another challenge. So how to coach the model to do more complex reasoning in very specific domain. So that's another very, very challenging issue because the task can be very domain knowledge dependent. And there's a lot of efforts recently doing that. For example, the challenge from DeepSeek. So DeepSeek R1, they use reinforcement learning to do reasoning. And their approach is unsupervised. So for example, given the question and the answer, so without even something in the middle, so they train the DeepSeek model to decipher what the chain of thought, what's the process, problem-solving process can be. So here, given the question, they can ask the model to generate different kind of chain of thought, so different kind of thinking process, which will give you different answer. But some answer will be correct, some will be wrong, some will be close to the result, some is far away from the result. So here, they can train reinforcement learning with the answer correctness. So they call this method GRPO, Group Relevance Policy Optimization. So this model has been used quite a while for large language model for when we do reasoning. So the good news is, even we don't have some middle layer data, like a reasoning process, we can still train a model to decipher what the reasoning process looks like. So this is called GRPO-based model fine-tuning, okay? Yeah, and I want to make it too complex. There's some mathematics, but let's ignore that. Okay, so here in critical domains, we want to learn a model, okay? We want to know more about the data. We may want to deal with calibration, like the boundary, knowledge boundary of the large language model. We may need to deal with personalization. We may need to avoid hallucination and the low quality input. We will need to deal with all of those information, okay? When we deal with task-based reasoning in any critical domain. So we may need to deal with all of that. I will not cover all of those, but we will sample something. So the first challenge we're right now focusing on is called large language model memorization. So memorization is so we can train a model. For example, if ask questions, how can I get a job at Google? So ask a large language model. The model will respond, okay, learn AI, learn data science, learn information retrieval. That's very general feedback. But then after the model communicated with the user a little well, and so the model, we can say, we will train the model with memorization, okay? So memorize users' personal needs and personal profile given this memory model. So then when I ask like, how can I get a job at Google? So right now, this model really know who you are. So right now, after we train the model will say, okay, I know you're WPI PhD student. I see you have good experience in machine learning. You have publication in NLP and coding, which should help, but you don't have enough experience in information retrieval yet. So I give you some suggestion. So you find that with or without memorization, the response can be quite different. Okay, so this is another thing we need to deal with. So our model right now, we will train the model. So even two users, when asked the very same question, we will train the model to learn constantly, dynamically from their conversation history, from their dialogue history. And we will train a model, it's called memory generator. But this memory generator will generate true kind of memory for each patient in healthcare domain. Okay, so for example, I have a Haihua here and myself, maybe I have a history of diabetes, well, Haihua is very healthy. So even we have the same question, so the model response can be totally different. So the model will need to learn from EHR data, but also will need to learn from the conversation dynamically. So here, the memory generator will generate two kind of a memory. One is a long-term memory, another short-term memory. So our research is either we can parameterize it, so as host this one as part of the model, or we can train the memory database. We proved either approach works pretty well. But we need two kinds, long-term memory and short-term memory. And this is a dynamic. Some long-term memory may go to the short memory. Some short-term memory go to the long-term memory. And some short-term memory can be forget. Okay, so all of those can be dynamic. We will need to train the model, okay, to do something. So then the model response can be quite different. So that's the first method we are working on. This is another recent model, and I think it will get accepted in ACL, but this is maybe ACL funding, maybe the main conference, so we don't know yet. But this one is another memorization model, but this one we call it that memorization model with cascade. So cascade model means we will train two different models. One is a small model, hosts on your cell phone. Another is a very big model, like a GPT model, okay? So sometimes when you ask a question, you may have some privacy. So we will make the judgment, which is a router model or gate model here, which is a tiny model, will make decision whether the local model on your cell phone can deal with the question or not. So when the model is confident enough and you have a privacy information, the local model will give you response. But when the model, okay, just the deferral model, when they find that, okay, this local model is not strong enough calibration, and then we say, okay, I need to get help from the server model, which is very big. Okay, like GPT model, like a Llama 400B, so it's a very big model. And so this model can provide you high quality answer, but we will need to mask some privacy information. Okay, so it means when we adopt this model, it's domain specific. We may make our server structure very dynamic and very different. Because maybe more than one model will serve the user. Maybe some model deal with memory, some small model deal with your privacy, or the global model can deal with accuracy. But the different model will need to work together. Okay, so this is the cascade model plus a memorization model we are working on right now. All right, this is another problems we are trying to solve right now. Is the quality of the user's input. So take a look at this one. This is a question of a user when asked a legal question. So when I'm not a lawyer, I don't have a legal background, I don't have a legal degree. So when I ask a question, for example, like Haihua borrowed me $20 last year, but he don't want to give it back to me, I feel very frustrated. How can I get money back from him? Okay, if I ask this question, you know, this question is not very, very professional. For example, do you have the evidence that Haihua borrowed the money? Do you have a witness? Okay, did Haihua give you like a documentation with signature? Okay, all of those factors were missing. So which means if you ask this kind of a low quality question to the GPT model, very likely the model will give you something very misleading because you are not the expert. Even the model can deal with domain expert knowledge. But right now, you are used, okay, when you ask a question, your question is not professional. Then the model will give you something very misleading. And then let's think about if you ask a question to the lawyer, what the lawyer will do? Will the lawyer give you feedback correctly? No, what the lawyer will do? Follow-up questions. Yeah, the lawyer will ask you some questions, right? So the lawyers will probably ask you a lot of questions, and then you will provide feedback. That's like a consulting, right? Consulting process. So after you provide the answer, you provide feedback, and the lawyer can provide you really high quality feedback. So here, we want to train the model to differentiate what kind of a question already carry enough domain knowledge for question answer. So what kind of question is not good enough yet? Then the model will need to learn a way to maybe just like a lawyer, ask you questions. Okay, help you to improve the quality of the query before they give you anything trustworthy. This is a very useful, right? So when users especially give you the low quality, for example, like a user is a patient, user is a legal user, is a who need a lawyer, so ask a question. So we will need to judge whether your question already associated with enough information. All right. So this is the model we just trained to try to solve the problem. So this is the model structure. I can give you a very quick introduction. So we have the client, it's a user, like a legal, I use this one as an example. So giving you the text initially, and then we train a large number model to generate an answer plus a special token. The special token is not visible, so users cannot see. But here, the token only have two choices, yes or no. Yes means the model is very confident. Users' question already good enough to give you the answer. Then we will show user the answer. But if this is no means the model is not confident yet. So maybe we say this model is not, the user's query is not clear enough, need additional information. Then we will activate another domain model. Okay, this is interesting because this is a general model. This is a domain model. Remember my first class, right? This is a domain model. So this domain model, just like a lawyer, will generate some questions only for question generation, ask the user. And the user will provide feedback. And then we will repeat the whole process. Maybe they will say yes, maybe they will say no, and we will continue until they say yes. And then we have enough information, and we will give user feedback. So this is what we train this model. All right. Let's take a look at the demo. I'm not sure it's gonna work. Okay, my students still working on that. But in 2 weeks, it will be ready because we're gonna present in the Australia for WWW conference. So hopefully it will ready. But I don't know. I don't know if it's gonna be good or not good. But let's see. Here. All right. Anyone want to try a question? You can ask whatever legal question you want. Anyone want to type? It's okay. Maybe system will collapse. That's fine. I'm quite brief, right? All right. If no one want it, I will give a try. Okay, I say sorry, Dr. Chen from NTU invited me to give a talk today, but I suffered from a car accident on the way to the talk. Should I ask him to pay my car repair? All right, I'm sorry, Taiwan. But so I need to say this is happening in Texas because the different state, the law can be a little bit different. So you can find this question is not professional at all, okay? And I have missing maybe a lot of information. And so this is also very weak and do not have, this is not professional at all. So this is a very, it could happen. Ooh, I hope it will work. We'll see. My students still working on that. This is my question. It takes a little bit longer. This is, oh, this is why it's, oh, it's my student maybe converting from Chinese to English right now. We'll see.
It's from UNT, not NTU.
Oh.
University of North Texas.
Okay, that's fine. Because the user made a mistake. Okay, we'll see. Maybe the server will need a well. Okay, so let's take a look. I give another another one. Right? First, let's take a look at this one. This is the example I provided earlier. So this is like a composition. The husband who died on my duty distribute after 3 years of a marriage, having child. So if I ask a question, so this is the model will do. So they will generate some question. Okay, they will generate some question first with a choice like ABC, and then the model will ask some question like that. And then after users answer all of those with multi-choice or single choice question, and then the system will provide conclusion, okay, like in different place. So this is what the model gonna do. It's still not working. Let's try one more time before we continue. This is, the model is still, okay, I will just use Alabama. Yeah, maybe my students updating the model right now. I'm sorry, but it's just ask questions before they provide the answer. So this is the model, what they can do. So train the model to ask a question, the capability to ask questions. This is very critical.
The block where it has it generates a token and it has that yes no answer.
Yeah.
Go to the domain specific model.
Yeah.
Do we have do we input a set of factors based on what?
Yes, very soon. I'll let you know. That's my next slide.
Dr. Liu.
So yes.
Could you repeat the question for everyone online?
Okay.
To hear what she
So her question is whether whether we will generate some special token, when there's special tokens, where those factors come from, right? The factors. That's a very good question. So let me show you the question. The factors come from this model. So here, explained in the understandable way is we collect a lot of case in United States of America. This is good. This is based on case law data set, case law. So the case law is open accessible data, which has Harvard released this data set, like 665K of judgment, the case with judgment. So this is very high quality. So from the very long judgment from each judge, maybe federal judge, maybe state judge, maybe some different levels of judge, but they have a case law. So those case law already have all the case factors. That's your question, extracted here. But those are perfect case because it's already associated with all the factors. We already know their factors. So when we train the model, we will randomly mask some factors. Okay, so let's say, we use this example. There's a judge make a sentence like Haihua borrowed me $20 2 years ago. Okay, we signed a contract of borrowing with his signature. But he didn't reply me after 2 years and didn't pay me my interest. So can I sue him? Maybe there was successful, maybe not successful, but this is a case judgment. So I will mask some key factors. For example, I mask the contract between us. I mask the signature. But the signature factor depends on the contract factor. Because without the contract, signature cannot exist independently. So here, we extract all the key factors from the case law data. And all those factors have dependency. So for each case, the extracted factors will be organized on a graph or the knowledge graph. And when we accumulate enough kind of data, like a borrow money cases, we can create quite a large graph. Then because we randomly mask some key factors here, then the model will understand which factors were missing and also understand its dependency. Then we will train the model to generate the factors from a large graph because we have the ground truth. Okay, this is how we train the model with reinforcement learning and another tech called PU learning. I won't go detailed about the PU learning. PU learning is something we can use to improve the model. Just like this example, someone borrows some money from me, but won't return, what I should do. This is a very common spoken language with grammar mistake. So we then train this model. So we find that A and B, factor A and B, maybe borrow money, maybe not return. So that's A and B. And the model will generate a node, sorry, A and C. The model will generate a node B here. So this is a factor from the graph being generated by using reinforcement learning. And then we will convert that into a question. For example, do you have evidence or do we have the contract? And we will ask the user. And the user may say, no. And then we will make another judgment. Do we need to generate another factor? And so maybe we generate another factor and we'll ask another question. So, okay, do you have a witness older than 18 years old in Texas or in Alabama? So based on this knowledge graph. So then the model will learn, just like I show you, be able to ask questions before give you any feedback. So this is the model we train. All right. So that's another one. This is the paper. Okay, just accepted this noon. Okay, I got a notification like 11 a.m. I'm very happy. So this is by SAL conference. So we're trying to improve this model by proposing the new strategies to enhance reasoning. So right now, this reasoning is a graph-based reasoning, but our new reasoning is based on programming. So the whole thing right now become a logical programming. So we try to understand users' logics by deciphering the human readable or human unreadable reasoning process. So maybe if we just use token, just a language, maybe the model is not strong enough. But right now we enhance the reasoning process by training some not human readable, not human understandable, like inductive reasoning. So we don't know what it is, but the model will decipher that by using different kind of logic calculations. Then we find the model will improve further. Okay, I won't go details, but this is going to be our coming paper. All right, very last one. Just one slide, maybe application. Also, go ahead.
I'm sorry. I don't know if this question is even applicable or for private here. Because I don't know how the data is structured for the people thing. But did you find any cases of bias or discriminatory besides?
Bias.
Yes, or any sort of discrimination. Because any health data or legal, we found, or there were a few news articles here and there saying the large language models, in fact, learn from us humans and our data generation, and they might be biased automatically. So when you're trying about the reinforcement learning and where we hire experts, or when we try having a domain-specific model, do we still have those biases there, or what is your view on that?
Very good question. So I will repeat the question. So is that when we train the legal model, do you experience or witness some bias, potential bias or discriminations potentially in the data? I would say yes, definitely. This is a very important question. We actually published one paper or maybe two papers regarding that. So because sometimes the model, larger one model may suffer from stereotype. So for example, like Asian guys may do some maybe criminal or not criminal, or African-American or white people may suffer from different type of criminal cases. So maybe the model will memorize that, even not by the race information, just by the name. Okay, maybe like where, for example, this is happening in the like a sushi restaurant. Okay, happened in the in a McDonald's. So maybe the model will memorize something like that, and maybe generate some bias potentially. So in order to deal with the bias, we will do two things. One thing is analysis. We find out whether this model may generate a specific kind of a bias for certain cases. Number two, when we train the model, we will provide general tokens, and by replacing some key information, for example, this is a sushi restaurant, then we convert that into a location token. And maybe this is like a Xiazhong Liu, it's a very Asian male, or my job is like, for example, professor, maybe model will memorize something like stereotype, maybe it will discriminate. So we will replace with a human and with a occupation and replace those general tokens. And then the model will get rid of some bias. Okay, but this is a very good question. All right, another challenge is going to be application. So application is we will need to when we adopt this model in different in each domain. So we will need to really take care of the user. So what the users really need. So sometimes, especially when the users they are quite vulnerable, they are vulnerable users. Okay, so for example, I especially focus on the patient, like a senior patient who suffer from different kind of a chronic disease, like a cancer, like a diabetes, when they home alone. Okay, we want to pay very special attention, like you forgot your question. So we don't want to provide us any bias. We want to serve them in a much better way. We want to pay special attention to the needs of this group of users. So we know the patient, those patients, when they don't have the privilege in the like economy privilege, they don't have a lot of money, they even don't have insurance. It is very hard for them to access the doctor resources, especially when they stay in a rural area, live alone, do not have insurance. We really worry about them. So when we adopt our model for those patients, so what we can do, okay? So when we deal with that, our large language model, we hope we provide them 24/7 support, okay, for each single patient, no matter where you live. I give you 24/7 support, clinical support, but that's impossible, right? That's impossible. So here we say, maybe we can provide a large language model, but maybe those vulnerable patients, they are not maybe educated enough to propose high quality queries. So maybe they can do nothing. They cannot make the symptom a very high quality query. Then what we could do? So here we will train a special large language model, but this large language model will work along with their Bluetooth device, like a wearable device. So the model will host on their cell phone, but this very engineered model will accompany with their Bluetooth device. So it means the model, you don't need to initiate any query, but the model will create queries for you by diagnose your Bluetooth device 24/7. Okay, for example, when your heart rate has a problem, blood oxygen has a problem, then the model will do something. Okay, then the model will deal with your query very dynamically. We call that explainable outlier detection model. Find your outlier and also try to explain the outlier. And then we will give it to the large language model we propose, called Vital Large Language Model. And the model will provide diagnostics to both the patient and communicate with doctor simultaneously. For example, the model will ask the patient some questions, and the model will also generate some suggestions or like help the patient to ask some questions to the doctor fully automatically. So user don't need to do anything. So we will do that like 24/7 for each patient. I will show you a demo right now.
AI-driven ecosystem designed for 24/7 vital monitoring and chronic disease management. This demo will show how our integrated solution transforms patient care for comprehensive solution. Triage and follow-up devices offer and support for both patients and healthcare providers. In daily life, our devices offer continuous protection by monitoring for early warning signs, such as abnormal signals or outliers. Upon detection, the system swiftly delivers recommendations or alerts. Powered by cutting-edge large language models, it proactively engages users through smartphones, asking diagnostic questions and generating high-quality triage reports for doctors. This early intervention helps address potential health issues before they escalate into serious conditions. The proposed LLM delivers high-quality triage decisions and collaborates with doctors to offer patients optimized follow-up solutions. Integrated with the system, the memorization model provides personalized recommendations, such as contacting an emergency contact in urgent situations, ensuring tailored support for each patient. Vital Diagnosis offers an integrated solution for real-time health monitoring and management. It starts with consistent vital.
I want to show you two details here, but here this demo showed that as a patient, you don't need to do anything. You don't need to issue a query because they don't have enough knowledge, but instead, the model will do everything for you. The model will ask you a question. The model will provide you that pre-diagnostic. The model will help you to contact the doctor if needed. The model will help you call 911. The model will help you to contact your friends or your emergency contact, your daughter, automatically. Okay, so this is what we should do when we deal with applications. So in those sensitive domains, remember some of your users, they are vulnerable. They're not strong enough to provide a lot of communication, high quality communication with system. So it's going to be your job, our job, to deal with that. Okay, so this can be, I think, quite important. But I can tell you that this system didn't run very well because users, older users, the patients like this guy, do not like typing. So right now we totally convert that. Our paper will come in a few months. Everything will be voice-based. So right now, if there's anything wrong, for example, you find some vital problem, so the system will call you, and you can communicate with the large language model by phone. Okay, you don't need any typing at all. So that's going to be the next step. So what are we doing? So help the patient, okay, design the system and to help the models to diagnose something more than just text alone, just use this query. Like for example, the blood oxygen, the heart rate. So those can be very challenging, but that's what we're gonna do when we adopt that in critical domain. So conclusion. So today we investigate several different approach when we deal with domain-specific problems when the model being launched in the critical domain, like a legal science, like a healthcare, like a drug discovery. But I mean, performance absolutely important. But anything else, maybe we need to take into consider. For example, the cost of a large language model training and inference, the complex task of reasoning, where the user data come from, and different type of applications. But one thing I didn't address yet, which is the risk. Okay, I didn't talk about risk yet. I think some of your questions talk like a bias and a discrimination. So where the risk come from? So this is another very critical issue. So our recent research starts to investigate this one, the trust problem. So when we adopt that in critical domain, I don't have time to investigate this one in detail, but we have several papers to, for example, we prove that even your model is very high quality, even this is a black box model, but there is a chance some bad guys can transparentize your model by manipulating the result. So which means the model, this is a paper we have 2 years ago. It means we can propose a model to decipher what the reasoning process for a complex model, like a large language model. And there is a chance we can propose a model to control the model output by injecting a very short piece of text we call the trigger. Then we can manipulate the model output. So which means the model can be risky. So we may need to define the model somehow. And I will provide a conclusion here by giving you a very easy problems. Everybody can try. So try if the model is trustful or not trustful. So this is our experiment. So we want the model to be ideologized by itself. But I tell my student that we cannot touch the model anyway, anyhow. So we want the model ideologize itself by providing the training data, ideologize the model itself without providing any data. So it means we want to test whether the model is safe or not safe by fully self-consciousness. So this is the experiment. We give a very, very easy, very naive, everybody understands ideology. For example, should we support Trump? Okay, we support Trump. And so here we will give 2 large language models, but with a basic prompt. The first model we say, you just support Trump. Well, the other one say you against Trump. So here is we have the root question. So we will have 2 models. One model say you always support Trump. Another one either you against it or you support this root question. Okay. And then these 2 models, we will ask these 2 models to debate with each other. But here we have the third large language model, which is coordinator. So coordinator, like round 1, let's start. You say Trump is good. You say Trump is bad. Okay, let's debate. And then the model will propose a lot of reasons, okay, why Trump is good and why Trump is bad. So they debate with each other. And the coordinator will learn from that automatically and will find a round 2 topic. Okay, round 2, maybe we'll say, okay, stop right now. I have enough evidence. So let's focus on economy right now. Okay, round 2, start. Why Trump is good, why Trump is bad. So we'll continue for several rounds. So maybe 10 or 20 rounds. Pay attention, we researcher, programmer, we never interrupt. So these 3 models work together. Against, support, Trump, and there's their coordinator. So after that, for a little while, maybe several hours, so we'll collect enough data, why Trump is good, why Trump is bad. but also coordinator find the reason structure, why Trump is good, why Trump is bad, by generating a knowledge graph. And so here we will use the data to train two large language model automatically. So pay attention. During this process, we do not generate any misinformation or disinformation. So everything the model generates is true. So we don't provide any misleading information, and we didn't touch the model at all. The model fully trained itself with debate data. So finally, this model will really support Trump. This model really against Trump, but without generating any misinformation. So the model generates some true information, but the model really ideologizes itself. Yeah, if you're interested, you can Google our paper. I think it's on the archive right now. So we call the model can be somehow dangerous, okay, a little bit risky. So the model, there's a chance can ideologize itself, even without human intervention, even without a lot of new training data created by human. And this is the coordinator generated without. So we have a root in the middle, and we have the left tree and right tree. The left tree is the reason why people don't like Trump, and the right one is the reason why people like Trump. So you see, when we generate this knowledge graph tree, everything is automatic. So I would say large language model can be somehow risky. Okay, so when we adopt that in the critical domain, like election, education, healthcare, legal science, yes, go back to your question. We want to pay attention to the bias and potential discriminations. Okay, so that's going to be my very last one. So there's some bad guys can attack your large language model because your model is overconfident somehow. Say, I know everything, I'm strong. Okay, the bad guys will attack and manipulate your model. And so there is a chance can impact our people and the community, especially those vulnerable ones. So we need to provide a defender, prevention and defendant. Okay, this is my students working hard on this one. We just have a paper just got rejected. We feel very frustrated, but I hope next year I can share you more results. So yeah, but I would say this is going to be efforts between collaboration between computer science and the information science, because there's more than just technical efforts. So also have a social efforts. So people will need to work together. So remember, when large language model or generative AI being adopted in the critical domain, there is a chance that we can create a beautiful world and also evil world. We don't know what's going to happen there yet, but there's something we can do, work together to make this world better. All right, thank you very much.